Good morning, everybody. My name is Mahnaz, and I'm the Vice President of Policy for Critical Supply Chains at Silverado Policy Accelerator. We're a geopolitical think tank based in Washington, and we do a lot on critical minerals, both on the commercial side and on the defense side. So welcome to our panel on innovation in supply chain resiliency and security. We heard a little bit about innovation in the last panel, but we're going to dig a little deeper, no pun intended, with on some of these issues. So innovation, it doesn't get the same headlines in the critical minerals sector as traditional mining and processing. When we think about critical minerals, we think about putting a shovel in the ground, and if it makes economic sense, processing some of the minerals here. But for decades, our strategic competitor, which is China, has made a patient, deliberate bet in critical minerals, and it's been a decades-long bet in this space. So even in instances where China lacks the feedstock itself for many of the critical minerals and rare earth elements, it controls the processing nodes of the supply chain, and that's not by accident. So you probably hear this a lot. We're not going to outmine or out-process China anytime soon. But what we can do is leapfrog China through innovation, and we have great panelists today that are in that space and can talk to us a little bit more about the new technologies in this space. So I'm going to let them introduce themselves and tell us a little bit about your company and which part of the innovation supply chain you're in. So Jacob, go ahead.
Perfect. Thank you, Jacob Clayton. I'm the CEO of SAGINT. And we build digital asset infrastructure, traceability systems for critical minerals. And as we have in a few press releases, we're doing this for ReElement Technologies, and Ben Kincaid was just on this panel, among other customers. And what essentially we're doing is baking in the compliance, bankable information, so the continuous underwriting process as they're doing production. And what that does is accelerate your ability to gain access to markets, but also to finance your outputs.
Good morning. My name is Kelley. I'm a senior advisor with the National Security Commission on Emerging Biotechnology. So I'm the only Fed up here, and I have notes for myself. So thank you for bearing with me. But I just first want to thank the Irregular Warfare Initiative and Special Operations Association for having all of us here and for hosting this really timely conference. Just for awareness to folks in the room who may not be familiar with the Commission, we are a bipartisan legislative advisory body that was stood up by Congress for Congress through the 2022 National Defense Authorization Act. Congress does this from time to time when they see an emerging technology on the horizon that they anticipate needing to legislate against, but they recognize they don't have the requisite expertise to fully scope the issue set. And so they bring some experts together for a short burn sprint to recommend legislative action to secure leadership in that technology. They've done this for cyber, for AI, and now for biotechnology. The commission has 11 commissioners. What makes us unique is that 4 of them are sitting members of Congress. Our chair is Senator Todd Young from Indiana. Our vice chair is Dr. Michelle Rozo. And then we have 3 other members of Congress and various industry and academic and former government experts. And over the course of our last 3 years, our doors closed this coming December, but over the course of our research so far, we arrived at 49 recommendations to strengthen U.S. leadership in biotechnology, and many of those recommendations would have direct implications on the strength of U.S. critical mineral supply chains. And so that's what brings me here today.
All right, good morning. My name is Alex Warthen. I'm the head of government affairs for Phoenix Tailings. We're primarily headquartered up in New England, but I work down here remote in the DC area. Got an office over in Crystal City. So this area in Northern Virginia is my primary battle space for the company. What we do at Phoenix Tailings is complicated and straightforward at the same time. We primarily focus in on using recycled sources of material as feedstock for heavy rare earth metallization. And so we have the ability to go from the extraction piece using tailing ponds, waste streams, and traditional below-ground sources of feedstock, and taking it from extraction through concentrate, through various forms of oxide, and then from oxide to metal. And that's currently right now where we stop. I get asked the question all the time if we make magnets. The answer is no. As of right now, we don't plan on getting in that business. But our primary customers are going to be on the high-performance magnet side. So where we play in to the great game that we're all now a part of is from a defense industrial standpoint and from a national security standpoint, because I think what often gets lost in the conversation, the defense piece is the sexy part. But when we think about national security, you think about it historically, okay? And I'm a history major, former Marine infantry officer by trade. So when I look at this picture, right, and we look about how you prevent wars and then how you win them, okay? When I had the privilege of teaching young captains and lieutenants in a previous life, I used to tell them that history is replete with great tacticians, people who won battles, but ultimately still managed to lose the war. And there's a long list of those folks. And the reason they lost is because their side had inferior logistics and inferior lines of communication. And the way that you deter aggression strategically is by having a very strong industrial base, not just defense industrial base, but industrial base that is capable of adapting. If in that worst case scenario you find yourself in a fight against another nation state, the way you're going to win that war, and it pains me to say this as a former infantry officer, but ultimately how you're going to win that war is you're going to outproduce the other side. You're going to out-innovate the other side, and you're going to win in that strategic OODA loop of being able to build better and faster. But if you can present that, hopefully you can prevent that conflict from taking place. Where Phoenix Tailings fits in is our ability to go from that waste material that is primarily domestic all the way to metallization, is that we hope it makes us immune from global supply chain shocks, like the kind of shocks you would see in a global conflict, because we can keep the lines hot and continue to produce no matter what is happening overseas. Whether there's a war, a coup, a typhoon, any of the other things, a pandemic, any of the other things which we've seen over the last 6 years that have major disruptions in supply chains across the world. The idea and our goal is to make the nation immune to those on the heavy rare earth production side. So that's what we're aiming at. That's why we're here. And again, thank you to this organization. I'll be honest, when I wasn't on active duty, I wasn't always the biggest fan of folks on the JSOC SOCOM side. I can tell you those stories later, but it looks like everybody here has a fresh shave, so that's a good thing. All right, glad to be here. Looking forward to the conversation.
Great. I'm Sam Kalirai. I lead products at SILA Nanotechnologies, specifically in the defense space as well as emerging technologies. Just wanted to kind of situate you guys about where SILA is in the supply chain. So we're a battery materials company. We kind of looking at the bottom, there's raw materials. You have the processed materials. Those feedstocks go into what we convert into advanced materials that go into the battery cells. Specifically, our first products are silicon anodes. And our leverage is that we're innovating into new and novel materials for the battery industry and remapping the supply chain, which is today compromised and specifically focused within China and dominated by graphite technologies. So we think about supply chain through displacement, through innovation, and remapping supply chains in that sense. Beyond that, of course, we also want to kind of leapfrog technologies, and so we have a specific impetus or imperative to define, refine, and ultimately realize at scale novel technologies that outperform existing technologies. So we find those two facets of it the critical to kind of wresting control from China-dominated supplies.
Thank you, Sam, and thanks to the panelists. So we have digital infrastructure, we have biotechnology, we have waste to metallization, and we have new battery chemistry. So lots of innovation just on this panel. Jacob, since you're sitting closest to me, I want to talk to you a little bit about your product and your company. We know China is in this space. They have a lot of shell companies in various markets. I do a lot of work in Africa. They transship through third countries. They mislabel cargo, and that's beyond critical minerals. It's in many other sectors. So can you just, on the verification part, what and where your company is, in irregular warfare and gray zone competition, they hide their origins of critical minerals. Another area we're looking at very closely is along the Mekong River, where we see a lot of heavy rare earths in going from those areas into China for processing. So how does your company have these tracking tools to bring transparency to these opaque supply chains?
I appreciate the question. And, it would take, I think, a few hours to go through every nexus of decision points that you need to make to do that verification. I'll highlight, and I think there are two sponsors here, Wirescreen and Sayari. I would look at what they're doing, investigating the entities and the entities behind the entities and where that capital is coming from. That's a key element of verification that needs to happen. What is our process, though, is a little different. We work with the mines, the refining, the product companies, and we ask them to essentially gain access to their ERP, to people on the ground, and IoT sensors. So we're pulling direct information from their process. We map out their process so we know what their feedstock was, what their process was, and what their output is. We use digital ledger technology to ensure that everything's traceable, immutable, and auditable, and zero knowledge proofs to protect proprietary supply chain information while revealing the compliance answers. And we've decomposed 108 compliance regimes into Boolean tests. So we test that data to answer that information on the spot. That requires some sophisticated, industrial processes there. So it's a little more difficult when you're trying to do this for artisanal, small-scale mining, but it's still doable. Because ultimately, out of that word soup I just gave you, ultimately, what you're trying to do is get the miner or the refiner to attest to what they think they're producing, where it's coming from, et cetera. That gives you a baseline. That baseline, where other great companies can come in and do a verification of that, is really part of the secret sauce. But the other part, and why we anchored the system and constructed it the way we did, is we base it on mass balance. You cannot break physics. You cannot take in 1 ton of feedstock and produce 2 tons of product. That number should be less, right? So the key point here is we do mass balance reconciliations, and we work with like Argonne National Labs, who we have agreement with. They're checking all of our math and science to make sure, okay, that physics model, that works. So that's a high level how we do it. But also, when you talk about one node, you can lie. You can lie on all the attestations, and you can try to catch them and verify what they're producing. The magic comes in, and this is Claude Shannon, information entropy, the measurements multiple times. So every time it goes to the next node in the supply chain, there's a check on that previous data. And that creates that immutable ledger that enables you to say, is the representation risk high or low? If it's high, there's probably not a good surety that in fact what they're providing matches with the physical universe. If it's low, there's high surety.
And Jacob, just out of curiosity, what's the hardest part of the supply chain to trace?
It is the transfer from one node to another. It's one thing to set up your infrastructure and you're consistently pulling quality data feeds, but once you add in transshipment, once you move that product from one node to another, because there are multiple steps here, and these supply chains change. They're not static. They're living organisms. So it's measuring that difference and what happened or what potentially happened to that shipment in between those nodes. That's the greatest challenge.
Very, very interesting. Hannah, I want to go to you. We are hearing a lot more about biotech in this space, but if I'm not a biology major. If you can break down what biotech is, as if I'm 5, and how it's used in the critical mineral space and how it can be a game changer, that would be great. And also, is China in this space as well? Are they using biotech for critical minerals, if you know that?
These are great questions. First of all, thank you for teeing up living organism, because now I get to talk about living organisms. So great questions. Biotechnology at its core is the ability to engineer biology to have the output that you want. So when you think about traditional uses of biotechnology, things that might be in your fridge, like a can of beer, we know how, you ferment beer. You have a microorganism that, usually a yeast, that eats a sugar that spits out something that is useful, that we can process into something that you want to drink. Biotechnology is being able to engineer at different stages of that traditional process to have very specific outputs. So when we think about, for instance, biomining, traditional biomining, we've been doing across the country since the 1970s. It's the use of a microorganism or a biological system to recover critical minerals. What's new is that we can now create enzymes, we can engineer enzymes that specifically target and extract critical minerals from complex mixtures. So think mining waste, disused electronics. And so using those custom designed proteins, they act almost like microscopic robots. It allows us to engineer microbes to separate high purity rare earth elements and other critical minerals with unprecedented selectivity. At scale, this new method of sourcing could complement traditional mining techniques. It likely wouldn't replace them, but it would help meet our domestic demand for critical minerals, mitigating the economic and national security risks inherent to our over-reliance on China. The reality is that China has made biotechnology a strategic priority across the board for the last 20 years. The United States has not. So they're exploring every application space and every strategic advantage that biotechnology can offer. For obvious reasons, they are in a more comfortable place on critical minerals than the United States is. So I think it's safe to assume that we are exploring these alternative options or these augmenting options probably with more urgency than they are. But just to say that they are pouring every resource and every ounce of expertise across the country into developing biotechnology that can enable applications across sectors. So something to keep an eye out for.
Yeah, it's clearly written in their five-year plan to use biotech. Besides your organization, what other agencies are in the biotech space, just for our audience that you know of?
A little bit of everybody, which is actually a great question. So as I mentioned, the United States doesn't have a national strategy for biotechnology. We don't have a coherent way with which we are moving out across the interagency to get at the issues at the core of biotech. And often when folks think of biotech, the way I thought about it 3 years ago, because I don't have a STEM degree, is that my brain immediately went to pharmaceuticals or immediately went to agriculture. What we try to land with members of Congress and with counterparts across the interagency is that it is a manufacturing discipline at its core, and that can sometimes mean that you're manufacturing food, and it can sometimes mean that you're manufacturing therapeutics. But it can also mean that you're manufacturing things like critical materials, like your textiles and plastics and chemical inputs for commercial and defense applications. And because it is so cross-sectoral, there's a little bit of biotech in every government agency right now. There are, and I would say to varying degrees of prioritization. So, for example, ARPA-H is doing a lot of biopharmaceutical innovation, a lot of research in the health space. There are some nodes across the Department of Energy that are looking into some of the critical mineral conversations among other application spaces, but we don't have a national coherent strategy for it. And so those different shops operating at different component parts of the biotech sort of vertical don't necessarily talk to each other. They don't necessarily share innovation breakthroughs that could be cross-cutting and enable different applications in other spaces. So I won't give an exhaustive list, but any agency you can think of probably has a biotech person, if not a biotech shop. The resourcing and the funding and the connectivity to other departments and agencies varies greatly.
That's a common sad tale. I used to work in government for 14 years, so I know that very well, giving me flashbacks. Alex, I want to move on to you. Phoenix Tailings is at the forefront of some innovative work using waste. We know that China has gone all over the world locking up rare earth feedstock, so I think the waste play is very interesting. So how does waste change the geopolitical leverage that China has over us, and how do you scale these refineries, these waste refineries? Because we do hear more and more companies coming into this space. So I know you said a little bit in your intro, but if you could elaborate on that, that'd be great.
Yeah, sure. Thank you. Well, first and foremost, it's the way that we got pushed into using the waste streams was mainly through necessity. And you pretty much spoke to that. 10 years ago when the company was just getting off the ground, that was one of the first challenges that the founders noticed. You're like, hey, where are you going to get the feedstock? So it forced us to have to sit back, look at the whiteboard and be like, okay, where are we going to get the stuff? Because 10 years ago, your below ground sources outside of China and Australia, there were definitely opportunities that were emerging, but very limited, and especially for a smaller company like ours to gain access to. So it was really a bunch of very bright people, geniuses really, who were like, hey, based on some of the white papers and other research that had been done and lab scale work that had been done, like, hey, we think that this is a not just a stream, but maybe even a solution ultimately, to the challenge. So we got driven into that direction purely through necessity. If the below ground sources of feedstock had been readily available, that's where we would have went. Ironically, at roughly the same time, I was in the Pentagon, like a lot of other people at that time, watching with frustration as China was eating our lunch in the Belt and Road Initiative in places like Sub-Saharan Africa and some other places in the world where we were just getting out-cycled continuously. So it's interesting to see those parallels personally in terms of as Phoenix Tailings was, it was 12 people around a pizza box and an idea. I'm in the 5-sided building going like, man, we have got to get smarter, faster, or we're going to be in a pretty significant world of hurt here strategically. But yeah, we got pushed in that direction. In terms of the challenge, what we have seen so far, especially for a smaller company when you're trying to do something like that domestically, is that everywhere you go, for instance, if my CEO were here, he would tell you that in the state of Colorado alone, there are roughly 20,000 tailing ponds, right? Now, not all of those tailing ponds are viable for our use, but all of them can be useful in some way, shape, or form to the various industries. The challenge we've run into so far is just, every tailing pond is going to be different. Every waste stream is going to be different in terms of not just its composition, but for my role from a government perspective, it's, the permitting, who owns it, what role the state plays, local government, if it's federal land or, depending on what it was. In many cases, you're talking about operations that have been defunct for several decades. Particularly for us, we look at active or defunct steel mills because we know in those tailing streams we're going to find what we're looking for. But the challenge that I've run into personally with this is just, you've got to assess, the people on the technical side, they're going to do their thing. They're going to take the samples and assess whether or not the waste stream is viable and has enough of what we need in it to where we could take it and turn it into that concentrate, which we have to do on site, which creates some logistical challenges that we have to work through. But for me, it's working through the local to state and sometimes federal bureaucracy in terms of all the permitting that's required in order to get those miniature extraction operations off the ground. Still, that's still much faster than starting a mine. So that 2 to 3 year process of working through that initial bureaucracy, still, when we talk about speed to market, is much faster than getting a mine off the ground and started, which is still, even with the progress we've made, a 15 to 20 year process.
Thanks, Alex. One follow-up question. We see, before Department of Energy was very much in the circular space, they still are, and then we've seen Department of War play more in this space. So what can, on the defense side, what else can Department of War do on the recycling piece specifically? Because this is not a traditional area for them. Is it more funding? Is it more initiatives?
I think from a funding perspective, again, I say this selfishly, I think we're doing pretty well. With this administration has been very aggressive in terms of pushing out the funding and making the funding available. The challenge for us from a defense side when we're engaging with the Department of War specifically is trying to get clarification on the specific requirements. And what I mean by that, traditionally those of us who know and understand that system, if the Department of War needs a new fighter plane, they will give out a specific list of requirements to say, hey, we need this next generation aircraft to do these 22 things. Lockheed, Northrop Grumman, General Dynamics, go figure it out and give us your best prototype. What we have found is that when we're engaging the Department of War to say, hey, what do you need us to make you know, when and how much. It goes into this very opaque and difficult process where it's like, hey guys, like, we get it. We understand all the classifications and everything else. Trust me, the Chinese know where our gaps are.
Yeah.
So tell me what you need and I'll make it for you. But if you make this difficult for me, I'm a business. I'm going to go someplace else where the people know what they want, what they need, and can tell me, because I've got to design and build lines to feed, you know, their needs and demands. Making this stuff is hard. So if you make it hard for me to know what you want, I'm going to take the path of least resistance, which for us, understanding our role in the defense industrial base is frustrating, because it's like, guys, just give us a straight answer and we'll build you what you need. That's the one area right now where the Department of War can help us out, is by being more clear on those specific requirements. So
Yeah, and I feel like China knows all the requirements better than we do because
They're
of
well
their
aware.
export control documentation. They know every single piece of rare earth element that
Yeah.
and where it's going. So
Absolutely.
it's unfortunate. Sam, I want to go to you next on battery chemistries. We know China has also spent decades in this space on refining battery grade graphite. And they have export restrictions since I think 2023. And so we can't outmine or outprocess them. So your company is very interesting in that there's a partial substitution. It's not the full elimination of graphite, but there is a way for us to get around these export restrictions. So can you talk about that substitution as a strategic shield and how innovating can shield some of us from these geopolitical bottlenecks?
Yeah, I think maybe to repeat back a little bit about what you said, you know, China dominates the battery market as it pertains to all facets of it, all the way to process technologies, which they've also now export controlled, particularly for, you know, next generation materials like Gen 2 LFP or some of the high voltage materials that go into cells that could be used for defense applications. And so it's a real challenge for everyone to kind of integrate what is ultimately something of national security importance that directly runs through China. They control about 92% of anode supply totally. They control about 95% of graphite supply. LCO, LFP, all of that is running through China. And so what we do and the way we think about strategic supply chain resiliency is actually moving away from a lot of those classical chemistries and changing the foundational chemistry from, in our case, from graphite to silicon. And in fact, maybe a point of clarification, we can actually replace 100% of the graphite in the solution. We've actually demonstrated that wearing a fitness watch right now in which we have 100% our anode. But ultimately, I think, you know, that's kind of our view of what our strategic shield is being able to adopt and innovate into new technologies. That requires the three things from the innovator. I think one is a drop-in solution to the existing framework for batteries. So the technology that you develop and innovate on has to be able to drop into existing manufacturing capacity globally in order to integrate as quickly as possible and as seamlessly as possible and not require, you know, trillion-dollar investment in retooling of the whole industry. The second thing is on the performance advantage. I think it's strategic of us to not just think about innovating to replace materials with existing performance, but to innovate and actually leapfrog existing technologies, thereby, you know, allowing others to kind of have more of a value function with respect to the new materials, which may cost higher than what's coming out of China today. And I think the third thing is really around just kind of debottlenecking the supply chain and having policy kind of aligned to that. So I think those three facets, you know, innovators are looking at to try to develop new materials and scale them here in the United States or kind of in allied nations, and ultimately integrate and displace a lot of the dominance that China has.
Thanks, Sam. I welcome those that have any questions to come up to the podium, if you have any. In the meantime, I will ask a question to you all. Let's say we're in a wartime scenario, maybe in the Middle East, and we needed these resources, and it's a long, drawn-out war. Which technologies of yours discussed today, what could you do in the immediate future that would be critical for immediate survival on the defense front? I think, Alex, you talked about some, but we can start with you while the others are thinking. And how would you address that problem? Yeah, but I'll ask the other panelists. But you were talking about war and defense readiness, so.
Yeah, a war in the Middle East that refuses to end. When has that ever happened? Right away, I think what we can do, like we talked about before, is utilize the waste stream advantages domestically. Like I said, to make sure that the lines stay hot. The key thing is, and I hate to sound cliche, but it's getting the materials that are required to the warfighter as quickly as possible. I was having a conversation with a gentleman before the panel where we talked about one of the things that we've learned, and I hope, God willing, this is not history repeating itself, but if you look at what is happening in Ukraine right now, for instance, and you draw parallels to the Spanish Civil War before World War II, it's being used as a test bed for a lot of the technologies that might dominate, the next set of battlefields, especially at the tactical arena. One of the things, however, that gets lost again in all of the sexy piece talking about drones and FPVs and everything else is that we're going to have to flatten our supply chains. Warfare is a nasty Darwinistic business, and the side that can innovate the fastest, ultimately, again, strategically, is going to be the one that wins. So what we can do and what we offer is the ability to fuel that innovation, because as part of that innovation, we know that there's going to be experimentation with different materials. You're going to need those materials now, not yesterday, not 2 years from now, but right now. And so our ability to help fuel the innovation, as brilliant people like we have up here on the panel are in that Darwinistic process where the warfighter says, hey, I need this thing right now. I talked about the procurement process historically, talking about the fighter plane. Well, in the past, that was a 20-year process. With modern warfare and human ability to innovate, now you add in AI and other technologies, that process has to be compressed down to weeks and months. So what we offer is the ability to provide the material that's going to be needed right now when that innovation is required, because that innovation is going to happen on the modern battlefield at speeds that we've never seen before. So we can't wait for the materials, and we can't wait for the materials to be developed. They have to be available now.
Sir, did you have a question?
Yes. Hi, I'm Sharma Peshapati from Penn State University. I have a question on the bio part and also on the secondary resources from Phoenix Tailings. From the bio standpoint, you clearly mentioned that there is no strategy for the United States, which I observed in our research here too. One of the things, engineered proteins, is landmodium. That is what we were working on, and a lot of people are working on, Lawrence Livermore National Lab, and so on. All these technologies that we're working on, even biomining, is all on the surface part of it. And can you throw some light on what are the developments that are taking place underground bio processing part of it?
Trying to think of the best way to answer this. The exciting thing about biotechnology is that it can address all of those different verticals of the critical mineral value chain. There are efforts, you mentioned, in various national labs looking at some of those more foundational component parts. I think what you brought up at the beginning of your question and what's really important to keep in mind is that when we talk about the United States not having a national strategy for biotechnology, the trickle-down effect of that is that projects that are looking at the thornier questions, the harder questions to answer, get less airtime nationally. They get less funding. They get less connective tissue to other efforts across the interagency. They get less visibility within the department itself. And so trying to get those applications to scale are really difficult. Without prioritization from the top levels that trickles down through leadership, you end up with issues when it comes to biotechnology regulation. A biotechnology product for processing, for example, could end up triggering 3 different regulatory agencies at any given time based on the specifications of that technology. And those regulatory agencies have different timelines, different guidance, different processes. They don't necessarily always talk to each other. And so a product developer or a researcher considering developing a product is just faced with this complex morass. Another issue that often comes up is obviously commercialization, the infrastructure and the capital needed to scale these kinds of innovations. And not to avoid your question of what exactly the government is doing on the bioprocessing front, but just to say, like, there are so many barriers to even getting to the point of public announcements about some of these kinds of projects because of all of these earlier stage process issues that exist. And so there is work being done. There's really good work being done specifically within the national labs on small tiger teams, but they're not as visible and they're not as obvious to the general public. And that also means that they're not as visible to potential investors. They're not as visible to interagency folks who might actually want to leverage these technologies and scale these applications. So I think there's a visibility problem that I appreciate you for raising.
Yeah, one of the things that is happening with that is generally the problem is with the kinetics, the speed. So we cannot use it as a raw technique or the front end, but the back end purification we could probably use, and we have seen a lot of success at Penn State with that part of it. And the TRL levels are generally around 3 to 4, and going up to 7 or 8 is a challenge. So I think for the final purification that may be, but I was more interested in underground processing, straight away injecting these enzymes straight into the ground and process it there instead of bringing it up or processing it. Again, one of those things applies to fly ash, actually. Fly ash things. I think Phoenix Tailings is working on fly ash, getting rare earth elements from fly ash, actually. In reclaiming the fly ash or the landfills or wherever we have put all these things, if we selectively plant certain species or certain trees, they can absorb these things and grow. But these are, again, limited sites. These are not like, widespread or we cannot have them anywhere, like arsenic and so on and so forth. We can selectively bring them up. So are there any efforts when it comes to fly ash aspects of it? You absolutely are right in variability of the resources. All secondary resources are variable. I just don't want to take up all the time here, but they are variable. Are there any specific criteria that you are looking for in harnessing this secondary resource, particularly fly ash?
Okay.
Thank you.
Okay. Well, first and foremost, as I remind everybody on Capitol Hill, I was a history major for a reason. So from a technical standpoint, number one, broad generally, you're exactly right. With fly ash, number one, I know two things. The chemistry is difficult, but there's an enormous amount of potential there. And you talk about Penn State, Pennsylvania, West Virginia, Wyoming. We've been doing a lot of sampling and experimentation with the coal ash and fly ash that's available there. It's extremely promising in terms of what we've seen so far, but the technology for fly ash is not there yet, but we see it happening here in the foreseeable future. But from the technical standpoint, I would have to take your question and turn that over to the folks who are much more qualified, the folks with PhDs from MIT that could give you some additional details on what we're doing with that. So.
All right. I appreciate it.
Thank you.
Thank you. I think we have time for one last question.
Thank you. Vladimir Brezhny, founder of K66, based in Texas. So, Alex, question to you, since you mentioned Ukraine. Ukraine serves a rapid qualification environment for allied critical minerals and magnet supply chains. What, in your opinion, would the U.S. government need to do to translate that real-world demand and feedback into faster procurement and investment decisions?
Yes. Circle of trust here, right? Okay, good to go. I'm going to give you my opinion on it. This is not the opinion of Phoenix Tailings. This is the opinion of a person who spent 25 years in the Marine Corps and just knows a lot about that business. What we need, for those of us who are old enough to remember the last great game we played in the Cold War, we had a whole-of-government approach that was able to survive the swings from administration to administration. And we were able to keep our eye on the horizon in terms of whether it was a Democrat or Republican in charge, who had Congress or whatever. We understood ultimately the strategic end game, and we made changes on the edges but we kept rowing forward over 50 years. We have to repeat that here. We need a whole of government approach that recognizes the need for innovation, rapid innovation, that can flatten some of the decision-making cycles, but also has the ability from a strategic standpoint to survive the wild fluctuations from left to right that we're going to continue to experience in this age of dueling populism for a little while. Ultimately, that's the answer. My big concern is that what we're seeing and learning in Ukraine is going to get lost in the political static, and we're going to relearn those things on our own battlefields, which is the worst case scenario. So I think maintaining that open dialogue and really smart, innovative people within the Department of War, Department of State, and other places, forcing us to not ignore those lessons, and behind the scenes, making sure that we establish that whole of government approach that can survive the wild fluctuations and swings in the electorate that we're probably going to continue to see for the foreseeable future. So, yeah.
Sam and Jacob, the last question is to you both. If you can tell us how your technology or your company can be a game changer in a wartime scenario. If you can just let us know real quick, and we'll wrap up the panel. Jacob, I'll start with you.
Awesome, and I'll touch on the bit of the keynote from this morning. A lot of what we learn in the counter threat finance, arena is there are a host of touch points that China has in our supply chains. We know that because anytime we put a TV in a skiff, we have to completely decompose it and rebuild it from scratch. Now, when we're in a conflict scenario, we can be assured that China's going to have a host of cunning measures to be infiltrating our supply chains and disrupting them. The only thing that I can credibly say is right now we are flying blind in our supply chains. $500 billion, and this is in a public report Department of War put out September 2025, $500 billion around contractor-held property and stockpile, zero accountability, don't know where it's at. And it's being looked at, they're gonna write that down, which is insane. And that's not even the full story. So accountability, and as a fellow Marine, I can tell you we care about accountability. And the Marine Corps actually passed their audit, in the Department of War. So accountability, traceability, understanding what elements we have out there, where the vulnerabilities are at, that's I'd say a majority of the fight, because then you actually have a map. Because this is going to be an economic warfare, engagement that could last the next 50 years. And I'll just end with, I wrote in detail a response on this in CSIS, Economic Warfare and Military Power, and I go through it in detail.
Thanks. Sam, you get the last word.
Great. I think from SILA Technology's point of view, we are ready. We have a somewhere between 2 and 5 gigawatt hour plant that's producing anode materials today. We just yesterday announced another $300 million private raise to scale that to 10 to 100 orders of magnitude. That's way more than the battery demand for our defense industrial base, which is around 600 to 900 megawatt hours a year. We are actively trying to integrate our materials into the technologies that ultimately kind of feed into conflict operations, et cetera, but also into national security operations. We are moving into producing cells ourselves to address a lot of these needs, because a lot of the supply chain, even post us, doesn't exist outside of China. So we're actively developing the materials and the solutions to integrate into the technologies that ultimately will win us conflicts in the future.
That's great, and we're at time. Thank you, Sam, Alex, Hannah, and Jacob, so much. I learned a lot. I'm always learning a lot in this space on innovation, so give her a round of applause to our fellow panelists.